Hello, everybody, and welcome to class. Today we are going to be working on Unit 1, which is our, as I mentioned before, our first real unit of instruction in this class, where we actually dig into not only the tools that we are about to use, but the language that we're about to learn. The first thing that I'm going to say is that our main focus as we get started is making sure you have the right tools in place, because without the right tools, you can't do the work. And for us as coders, the heart of what we do in code is use a text editor to create computer code, but it's better to use a higher end text editor than generic tools that are built into your operating system. So I'm going to turn our attention actually to way to the bottom of this Unit 1 folder. And we kind of did this last week. So when we were kind of going through the process of installing stuff in class and we gave a demo, and Brock, you were very gracious at sharing your screen. And even though we ran into a little bit of a hiccup, that kind of stuff happens with computers. The first thing you do whenever you run into a problem is don't go into panic mode, is what I tell people. There's a solution. It's just a matter of finding the solution. And, this is really part of the fun of computing, right? And so if you don't get a little bit of a kick from like, hey, there's a problem, I don't know how to work my way around it, but you know what? I got the world of information at my fingertips. I should be able to come up with an answer. And here's the other beautiful thing. As we sit in this classroom here together, you have all of your peers as a resource as well, because maybe somebody ran into the same problem. It's like, hey, I figured out that problem. I can help you. Or you go to the internet, or you come to me, right? And the other thing is we also have our book as a resource. But what you discover with anything that's in printed form, by the time it's, written, edited, published, put on a truck, sent to a bookstore, and gets into your hands and you're reading it, how much time goes by? It sometimes is years, literally. So like anything that's printed in a book is sometimes a few years old, just from the moment you get it brand new. And so you will see like the Java install instructions that are included in our textbook are kind of antiquated, because at the time the book came out, it was modern, but then things change. So when we looked at this little thing in our last session, I had provided this link on our local gateway servers, which allowed you to grab the files that I've highlighted here in this image and download those. And for Windows people, for the most part, this is a pretty easy process. You start with the Java runtime environment, you download it, run the installer, you're done. Then you move on to what we call the Java development kit, or the software development kit. And that's all the tools you need to build programs. So you download that, run the installer, you're good. Once we have those two pieces, we move on to the portable version of Eclipse, which prepares you not only for this semester, but for the following semester when you take Java Programming 2, so you don't have a separate set of tools to download. And that has a bunch of different plugins built into it. It's pre-configured, it runs beautifully. And so that's going to be the preferred tool of choice for this class. Now, if you are watching some of the older videos that I have posted, I know that many of you have from the questions that I've fielded, I went through the process in some of those videos of going through talking about how to do Java from a command line and running a regular text editor, just like the chapter does. And I've made this conscious decision this semester to break away from that approach, because I spend a lot of time doing it. And if you heard from the syllabus, lecture, our semester's been shortened by a week. We went from 15 weeks to 14. And so I'm still kind of trying to squeeze in all the material. So the more time I can save getting right to the real tool, that's what I'm going to do. The other thing that I've done in some of those older videos is I also used a product called JGrasp, which is a great product, by the way, but it is really designed for academic work and lacks some of the features of a full-featured professional IDE. And because we are very focused here at Gateway, really preparing you for the work world, my mindset has become more and more these days, why work with academic tools, or why work with lightweight tools when you can use the real thing, right? So why use a handsaw if you got a sawzall with a battery on it, right? Or a chainsaw. You go for the chainsaw and get the work done and get it done quickly. And that's really kind of my intent here. So I don't want to introduce you to like command line coding and then go to JGrasp, which is an okay but primitive tool, and then switch over to Eclipse halfway through the semester, which was my old pattern. I've decided to go directly to the main tool, because the sooner you start learning, I think the better off you're going to be. And if this is the only class you're taking here at Gateway, which is the case for some people, at least you can leave knowing Eclipse fairly well by the time you're done. And knowing the tool that most of the professionals use looks great on a resume, folks. And it prepares you for the work world, not like, hey, this isn't JGrasp, what do I do next? You know? And so that's kind of my mindset. So what I did is, aside from all this content that I have here, I added at the bottom, kind of prompted a little bit by what was going on with E during her install a little bit earlier this evening. And, you know, I noticed that I didn't have this link provided in this course shell in an easy location. So you know, it was this link in particular that I was worried about, which is the prepackaged version of Eclipse, the same one that I put on our Apollo server that most of you downloaded and installed, no problem for Windows. But what if you're on a Mac, right? So I was like, well, you know what? I never grabbed the Mac version. So I provided the link here. So I'm going to click on this link, and I want to describe what is located here. Basically, this is what we call a pre-built version of Eclipse, in the sense that it comes with the main Eclipse engine and the software development kit, and a bunch of key plugins that you need to do a lot of the other higher level work in this course and in future courses. And it's pre-built on a nightly basis. So this organization, there's just kind of like a bunch of geeks like us, basically, that grab the latest version of Eclipse, they grab the latest versions of all the plugins, bundle them together, and release them on a nightly basis for all these different platforms. It's got to be, you know, an endeavor of love, you know, as geeks often have in these fields, right? But here you can get the Mac version to download, or 32 or 64-bit versions of both Windows and Linux distros. So if you happen to be working like on a Raspberry Pi or a Linux machine running like Debian or Slackware or, you know, Ubuntu or whatever, you know, your deal is, you can get versions that should hypothetically run on that program. Now with E, you know, before class, we sat down and we tried to download this and get it to run, and then it seemed like her OS was blocking it from running. So we yet to figure that out. But E, I assure you that it does run on that platform, and if we can't get it to run, we're going to look at the other alternatives that I have posted here in the course shell as well. So I'm going to go back to those. So if you're looking for that build, if you're looking for different platforms or where I got that build from, this is where it comes from. Right. The reason I use that, once again, is because everything's bundled in. You just unzip it and run it, and it's great. And you know, I'm also calling it the official tool for the class, because that's what I'm going to use to do almost all the coding here. Now, I think it is notable and important to mention that there are other products that can code in Java. And you know, are you, because I'm using a particular tool, are you required to use the same tool? And the answer is absolutely not. You can use whatever tool you want, as long as you can get the same functional work done. And I'm going to tell you that I think the choice that you make here, you know, from experience, is you're going to pick the tool that helps you along the way the most. And I'm going to tell you which ones I think those are. So I think Eclipse is, you know, the preeminent tool because this is largely the tool of professionals, and the tool that, at least in the open source community, has the most amount of support and very active at doing different types of builds. Another one that a lot of our students are really liking quite a bit is from a company called JetBrains. And so anybody here that happens to be a web student, maybe beyond their first semester, which might be some of you, you might be familiar with JetBrains products. So JetBrains is a software company that creates coding tools for a variety of different languages. And if you start, you know, digging in here and looking at all the different things they build, you can see they have all these products here. These are all IDEs, you know, and notice how there's more than one, and some of them are very specific. So for example, if you want to code in Python, you can use PyCharm. Or if you're doing PHP, you can use PHP Storm or WebStorm for web pages in JavaScript. And if you're doing Java, which is what we're doing, there's IntelliJ, which is what we call their flagship product. So if we look at what Microsoft offers as their flagship product, that would be a product called Visual Studio, not to be confused with Visual Studio Code, which is a separate freeware product. So IntelliJ is really designed for Java, but it also supports all the other languages that you see here, and then some by virtue of plugins. So that's kind of their flagship. You can get software for free from this company by first establishing a student account. And what I normally do here is I come up here and I just type maybe student. I'm just thinking of what the search criteria is. And so notice I come up with this link, free educational licenses. Sounds like the thing to do. And so this is available both to teachers and students. And all you have to do is come to this page and click on apply now. So I'm going to give you a direct link to this if you're interested. This is not obligatory. So here it comes up in the chat. And the recommendation is before you download anything from this site, set up your account first. Make sure that you use your gateway student email account to set up the account. They will notice the .edu at the end of that email address, and you automatically will have access to all of their professional development tools for free. One little caveat, if you've already got, let's say, PHP Storm or WebStorm or any of their other products and have the educational license, that same license will work for IntelliJ. What I've heard from students about this product is they like this better than any tool they've ever used. I mean, I get such rave reviews about it. I've been thinking about maybe officially switching to it. So we may at some point, I may toy with this or demonstrate it in class a little bit. So now the one disadvantage of using this product is I'm not going to be always demonstrating it in class. So if you have a problem, I can only help you so far in some circumstances because the interfaces and the menus are different. But in terms of quality of product and feedback I hear from people, this gets 5 stars. It's kind of like a way to put it. And the fact that you can get it for free, where it normally is a very expensive product to license, wonderful. You know, so this is one of those recommended tools. Other things to consider. Now, I did mention this tool called JGrasp, and this is one that you see in some of the older videos that I have posted in the class. And JGrasp is another one of these free tools. And this one has a little bit more kind of an interesting story behind it because it was originally developed by students and faculty at Auburn University, you know. And so this is not a professionally developed product. It is very much kind of a community developed product. And what they did after they developed it is they released the source code so you can actually download it and build the source code yourself or whatever you want to do. And then you notice that they also have plugins for Eclipse and IntelliJ, and I've never explored those, so I can't vouch for them. But I think some of those tools allow you to bring some of the IntelliSense features that JGrasp is missing. JGrasp is a full-featured editor. So in other words, it can run any form or create any form of Java program. What it lacks is a slick interface that looks modern. It looks really primitive, you know, on screen. And it also lacks on-the-fly debugging. So in other words, as I'm typing code, it's not suggesting what to type next or telling me what to fix. I can only find that from the debugger, which I find to be a little bit of an impediment and therefore not really a professional level tool. However, in a pinch, JGrasp is full featured, so it can do stuff if you need it done, right? Going back to that list here, another product to consider real strongly is Netbeans. And Netbeans is the official IDE that used to be proctored by Oracle. And if you're not aware of this, Oracle is the company that owns the Java language and a bunch of other key IT things. But Oracle recently gave up control of their open source IDE called Netbeans to what we call the Apache Foundation, which is a different open source community on the internet. And so if you're interested in downloading that IDE, you can follow this link and find versions. Now, the newer versions, and I mean anything from version 8 on up, will work fine for this class because we don't really do GUI programming or database programming here. However, if you want to do more specific work, you do have to go to some of the old enterprise versions of Netbeans. I would recommend generally staying away from this product. as a whole, but when we do Java programming too, we do use it for some very specific things that it does well. So just a recommendation. Another product that a lot of you have already tried, if you've done any form of coding, is Visual Studio Code. And in fact, this is probably the hottest product out there right now. And what Visual Studio Code is a free lightweight version of a code editor from Microsoft. It is not their flagship product. So it's really important to understand that Microsoft's flagship product is called Visual Studio, which is not free software. It is for people in education and for what we call the community. And so you can go get the community edition of Visual Studio for free. If you're going to run Java in it, was it really built to run Java? It requires some special plugins and tools and stuff. So I generally would stay away from that product also. But Visual Studio Code, the lightweight version, does Java pretty well. That also requires a couple of plugins and that you'll have to kind of explore on your own. But what I thought was really interesting, and I remember seeing this story earlier in the summer, they had a browser-based version of VSC that was running. They experimented with it and then they brought it down, right? And a lot of people got really angry. It's like, I was digging this online IDE. So I'm kind of putting it out there as a possible option for some of you, is they now have the browser-based version relaunched. I have heard they don't consider it 100% stable yet. So they don't consider this, production. But here it is, Visual Studio Code running in my browser, and it is possible to code Java in here, provided you add the right console application. So you'll have to do a little bit of experimenting and discovery on your own to figure that out. But what this brings as a possibility to us, and this is kind of exciting, is that if you maybe potentially are on a Chromebook or something and have no way to code, this might give you a way to code when you might not have another opportunity. At the very least, you can create text files with it, so you can create the files here and then move them to your system to run them from the command prompt. All right, so that's kind of the quick overview, folks, of some of the software tool options that you have. And if at any point in time you're running into problems with your configuration, my goal here tonight is not to necessarily solve those problems in class. If they're simple, we might be able to. But if it was like E's situation, where it took a lot of downloading and waiting and stuff, we don't have time for that. So in that scenario, if you're stuck, what I ask that you do tonight is code along with us using any text editor that you have available, even Notepad, if that comes down to it. So you have the code typed out. And then set an appointment with me and we will work out your software issues, make sure that you're working, and then by next week, you'll be completely on track. If you run into any other little hiccups like that, we try to solve them as we go, but the main focus tonight is to get on track with the material. And so that's where I'm turning my attention next. So I'm going to jump up to the top of the course shell here. And the first thing I'm going to start by doing is just taking a look at what we're going to learn tonight. And my main objective really is having you understand what Java is as a programming language compared to other languages, what it means to program. Let's take it even more fundamental, looking at some of the ways that Java works as a language, and then starting to type up some really basic code. When we get to the point where we're typing up code, I'm going to go through the process of explaining what we're doing, why we're doing it, and then we're going to start working on the you do it exercises, which are assigned as homework here. So these are the in-chapter examples that are guided builds of little programs to demonstrate key features. So the way that this book typically works is they'll say, well, here's how you do this. And they give you a you do it exercise that gives you the step-by-step process of doing it. And then you execute it. And if it works, you've got one complete. And it's basically a tutorial, so it's in written format. I'll read it from the book. I'll demonstrate it to you. You follow along. We try to get it to work. And if we do, fantastic. From there, we're going to move to the exercises at the end of the chapter that are assigned. And those are the numbered exercises where usually we're given a very simple scenario. And then we have to figure out how to do it, rather than here's the code already done for you. And I'm going to walk you through that process as well. So really all you have to do to work through the exercises is come to class and basically watch me code and code along with me. And then at some point, I will kind of flip the script a little bit and have you guys share your screen and we'll coach you through the process. Or if you get into a situation where you're coding, you think you did everything correct and you're having a problem, you know, so normally when you're having a problem in class, the last thing you want to do is raise your hand and go, mine's not working, you know, and be singled out. But I want you to think differently about that. If that happens to you, I want you to volunteer. If yours isn't working, let's see why. Because first of all, we're going to help you fix it, so you walk away with code that works. Secondly, we collectively work on debugging. So we all go through the process of problem solving, finding errors, spotting them, and really training your eye and training your brain to spot these types of problems to prevent them in the future. You know, so this is kind of the you know, the overview of what we're going to do here tonight with the topic list, basically from the chapter, working with the Java platform from Appendix A, and then this required Java components. Now, I consider this portion kind of covered already. And like I said, if you're having issues with any of this stuff, let's really set an appointment outside of class to make sure it's working. And for those of you that do have the tool successfully installed, fantastic. Try to code along as I step through the material. The one thing that you will notice, and I am about to basically release the additional exercise videos I have here, and normally I do that before class. So when we take a break, I'll probably do it. But normally what I do here is I have, you know what I call my lecture-y things, you know, so you'll see, and sometimes I'll actually mark them lecture, but we talk about chapter 1, part 1, and there's a little bit of a walkthrough of Appendix A, etc. And this is exactly the stuff I'm doing here in class. If you've like already watched all of these videos, you might be a little bit bored here this session. What I will do in future sessions, so when we come next week, is I will expect that you've already absorbed this information, whether you watch the videos, read the book, whatever your format is, and then we will dig directly into exercises. Tonight, there's a little bit of lecture that kind of goes peppered in, right? But we will functionally get to coding pretty quickly. So what I'm going to do next here, you know, and basically we're going to work up to the point where we're working on these exercises and hopefully digging into the actual chapter exercises as well. But I'm going to first direct you over to the resources page on the sidebar. And I do this for those of you that maybe have purchased an electronic copy of the book. Has anybody purchased an electronic or rented an electronic copy from the book directly from Cengage through our bookstore? Has anybody done that? Nobody. Okay. I will tell you, I want to show you why I think it's cool to do it this way, because you can use the same link that I have on the resources page here. So I get it direct from Cengage. Now, granted, I don't have to pay for it, so that's one of the benefits of being a teacher. But if you do the electronic version from Cengage direct, you notice I'm pulling up the book right inside of Blackboard. I don't even have to leave Blackboard to see my textbook. And I think this is wonderful, you know. And I am going to take us directly to chapter 1. And what I'm going to start doing is I'm going to start kind of leafing through the pages and talking about the key concepts here. This is very much the format for most of my lecture videos, by the way. So you'll get a little bit of lecture-y stuff, but I'm not here to read the book to you, all right? So I'm going to hit what I think are the important highlights and points, and all the in-between-the-line stuff you kind of have to read for yourself, okay? So, you know, like I said, I'm not here to read the book to you. I want to hit the important topics, all right? So I'm going to start leafing through the book and talking about programming. And let's talk about programming as a concept first. Programming really is a systematic approach to solving problems by software. It's really kind of the best description I can give. So in other words, when you sit down to write a computer program, you don't just like, I'm going to invent a computer program and just start typing. It's kind of, I always use the analogy of kind of like building a house, right? If I want to build a house, I don't like zip down to Menards and buy like a whole bunch of 2x4s, a hammer and some nails, drop it off on my property and just start building something. You just don't do that. You have to have some sort of a plan or a roadmap as to where you're going. And so if I'm to build a house, I typically would sit down and think about, well, what kind of house do I want? How many rooms should it have? How big should it be? How many, where should the windows be? I would make a blueprint. I would plan it out. And computer programming is very much the same way. So often the process of computer programming is a process of problem solving first, and then converting the written solution into computer code and actuating it into software. So for example, if I want to create a piece of software that calculates something, well, I need to know what I'm calculating. I need to know the correct formulas for making the calculation. I need to determine what my inputs are for my user, and then I need to know how to convert that to code and have it work correctly, right? And that's part of a process. Now, what I don't do really heavily in this class, and this is with intent, is talk about pseudocoding on a heavy level. Those of you that are also in my Python class, and there's a few of you, in that class, we actually do a couple of units on pseudocoding, flow charting, which I consider pretty important parts of the process. In this class, we tend to take a more dive into code approach. I just want to give you that, but I do talk about pseudocoding and the process of planning. And what you will notice is as I start to solve the chapter exercises, I have a very methodical approach. Excuse me, what's being asked? How do I get there? All right. When we start to write computer programs, here's kind of a little analogy I got when I first started as a computer science student, many decades ago. My instructor at the time said to me, you know what? Computers are just dumb machines. They don't know what to do. They are waiting for instructions. When you hit that power button on the computer and you turn it on, what happens? The system talks to the hard drive. The hard drive loads up the operating system, which has all the instructions for how to operate Windows, right? Somebody had to create those instructions. It was a human being like you and I that created all those instructions. So all the stuff that your computer does, all the stuff that Windows does automatically that you don't even think about, somebody had to code that in. What we're going to be creating, in terms of computer programs, are programs that will run within the operating system of whatever platform that we're using. And so a computer program is basically a set of instructions telling the computer what to do with all its resources. So it might be like reading stuff to storage, it might be getting input from the keyboard, whatever the case may be, but it is operating based on our instruction set. That software operates on top of a hardware platform, right? So in other words, on physical equipment, so there is, the physical equipment part of it, but we're dealing really with the electronic information that's inside the computer, stored in the form of basically binary information, a series of electronic pulses, really positive and negative voltages, if you want to quantify it, that represent ones and zeros that are then translated into the higher level languages that we understand. So computers speak electronic pulses, little on and off sequences, ones and zeros, and those ones and zeros are then basically converted into higher level languages that we understand. So if you really wanted to program a computer on a machine level, what we call machine code or machine language, it looks like gobbledygook. It looks like a screen from the Matrix, it's all ones and zeros. And you can't really make sense of it because that's not how we were taught to read and write. We were taught at a higher level. And so when we write computer code and we write in language like Java, Java is considered a high-level programming language because the code that we write is very English-like. It is like the language that we speak so that we understand. So if we're, doing some math or saving something or moving information around, we can look at the words and understand them. When the machine gets that set of instructions, we go through a process that we call compiling, so checking the code for errors. And then if there's no errors, we turn the code from the high-level language into a low-level language that the machine understands, those ones and zeros, and then the computer can execute the commands. So it cannot go directly from the high-level language to the machine code. Now, here's something interesting for those of you also taking the Python class, because I know there's several of you. In Python, it's a little bit different. Python is what we call an interpreted language, meaning that it executes instructions on the fly. So Python is designed to take your instruction and run it directly. It never really truly gets converted into a low-level language. Well, it does on some level, but really you write instructions and Python executes them. The code is not compiled or turned into an executable. In Java, we write the code, it turns into an executable, and then we can run it. So that's kind of the procedure. Now, because we have to learn a high-level language, every language has keywords and what we call syntax and a correct way to put the code together in order to get the software to work. Now, what's great about Java is in essence what we call a C style language, the letter C, like in the alphabet. And C is a very important language in computer programming because C is the language that since the late 1960s has been used to do all operating system development, and more importantly, just about every other language is based upon it in some way. Either they use its libraries, or follows the syntax structure, or borrows many of the concepts from C. So Java falls into that category of language, and it basically does this. It forces a certain type of syntax and structure, allows us to create objects and classes, and then separates out our code into blocks using curly brackets and then delimiters of statements, which are semicolons. And this is a structure that translates into so many other different languages that once you know Java, the door is open, folks, that you can learn a bunch of other languages very quickly. And this is what happens in computer programming, just like in learning real human languages, right? So if you ever heard this adage, like if you're a little kid, right, learn as many languages to speak as you can. And I'm not talking about computer languages. I'm talking, and Krishna, I'm gonna point you out here. You probably speak both Hindi and English. Is that correct?
Yeah, because I know Hindi, English, and Tamil.
Okay, so, and I was going to suspect that he probably knew more than just two. And this is what happens when you go to foreign countries. I myself, learned Greek as my first language. English is not my first language. So I didn't learn English until I was about 4 or 5 years old. Thanks, mom and dad. But here's the flip side. When I was a kid, you don't think about those things. You pick up that Greek, English. It didn't really matter. You just kind of do it, and then you move on with your life, and multiple languages. I can think in both languages, dream in both languages, order a beer in both languages. That's very important, by the way. So this is kind of the same correlation that happens in programming. When you've learned that first language and you get the concepts will transfer to every other language. Then it's just a matter of what we call syntax. How do you do it in this language? Oh, okay, I know how to do that. That's just a little different than what I know. Often you will discover that the syntax approach to what we do here in Java will match so many other languages. You will feel strongly empowered, folks. And you get that first couple languages under your belt, the other languages come quick. Right? Just a matter of different syntax. And then we have a saying in programming, it's just another language, and it's true, very much. So Python came around, it was just another language, but you know what, you have to kind of keep up with the times too. And sometimes we get some really cool advancements. When we start to write our code, you will notice that we have things that we call keywords, so important words that are reserved for language functionality. We will take those keywords and arrange them sequentially into a series of steps. So first we do this, then we do this, and it reads top down in an orderly fashion. And the computer is not smart, remember, it does exactly what you tell it to in exactly the order you tell it to, exactly the way you want it to. And hopefully that's what you intended, right? Because maybe it's not and maybe it is. And we hopefully solve whatever issue we're working on. As we write out our statements, so complete statements using keywords and all the different names that we come up with. When we think our program is done, we will run what we call the compiler, in some cases, the interpreter is really more what we use for like JavaScript and Python, but the compiler takes the code that we have, checks to see if it is syntactically correct. So it's structured correctly, kind of like checking your grammar, or in your sentence structure. And if it's correct, it will allow the code to run. It will turn it into machine code, and then it will run. But even if your code is correct, and this is kind of the interesting thing, it is possible that even though your code's correct, that your logic is incorrect. So you might have wrote code that is, let's, for the sake of example, grammatically correct, but the logic of the message that you're sending is not there. You might be out of sequence, or you did it too many times, or it's the wrong thing, right? And so what we'll end up figuring out is there's this concept of looking at what we call runtime errors. So ones that where the code is correct, the program runs, but it's not doing the right thing, or basically syntax errors where the code itself is incorrect and you can't even run it. So you really, when you learn to debug and figure out problems, it's both of those things that we look at. Your grammar and syntax are wrong and your logic is wrong, but we have to have both of those in place to have a successful program. But they have a little graphic here. And, and I did tell you in the Python class, we do a whole bunch more of this, but often when programmers are trying to figure out a problem before they go to code, sometimes they think about the steps of solving the problem first. So for example, if I wanted to calculate how much it would cost me to buy a new house, like what's my monthly payment? Well, there's a formula that you can plug into where you can give it certain pieces of information, plug the numbers into the formula, and then there's your monthly payment. And that's really a series of steps. And what they attempt to do here is show like both in a flowchart format, and I think in what we call, like a pseudocode format, where you write out the steps of instructions, figure out all the steps that you need to get there, and then execute those steps into code. But it helps a lot to think about the problem solving process first, and maybe jot out a few notes. Maybe those notes are on your screen. That's fine too. Or maybe it's on a piece of paper. But you would be surprised how many programmers, when they're building programs, that they use tools like a whiteboard and a marker, right? Because they can write out an idea, erase it, move it around. And there's software tools that can do the same thing. But thinking about the process first and then going into the code is kind of an important first step. You might not see that as we write the simple programs here at the beginning, because the tasks will be simple enough where you can just go directly to it. But when you start to write like the final project for this class, there's no way that you can just jump in and write code. There is a process, and it starts with problem solving. And you will see that. So when we get towards the tail end of the semester, I will do a whole build of that project step by step. And you will see the problem solving process of it and how that aids our coding. It helps tremendously when the software gets more complex. All right. Going on to the next page here, folks. So the next thing we're going to talk about here is what we call procedural programming. And, procedural programming basically refers to this concept that we are going step by step. And I will tell you, like in the Python class, I do talk about the classical programming structures. And basically, we solve logical problems in programming using 3 different tools. The main tool that most of us think about is a step-by-step approach, which is procedural programming. And it's basically this. It's kind of like having a recipe for chocolate chip cookies is really kind of my example. If I was to make a batch of chocolate chip cookies, I would first gather my ingredients. That would be step 1. Maybe step 2 is preheat the oven. Step 3 is mix the ingredients together. Step 4 is put blobs of dough on the cookie sheet. Step 5 might be put the cookie sheet in the oven for a certain amount of time, maybe check it after a while, pull it out, take them off the tray, serve them. There's your recipe. What is the instruction set for that? Well, it's step by step. It's a series of procedures that we're doing in order. I cannot change the order of those steps, because if I do, it might not work, right? So that's really kind of a really primitive example, but that's one approach to solving software problems, is a step-by-step task approach, which is always basically used in programming, and it's always read top down and in order. There are other structures that we use too, but we will start with this one. And those other structures include repetition. So in other words, sometimes when you're solving a problem, you have to do a certain action over and over again. So for example, if I was making cookies, the process of like scooping up the dough and dropping it on the cookie sheet happens more than once, maybe a dozen times on each cookie sheet, right? Load 12 cookies, next cookie sheet, repeat, that kind of thing. So that's a different example. The other programming concept that is really important is a process that we call selection or decision. So you get to like basically a fork in the road, and you can't go both ways. You have to either go left or right. And those are usually based on true-false decisions that we make. And so basically, the three basic structures for solving programming problems, folks, are what we call sequence, selection, and repetition. And that's a good thing to kind of remember. I hammer that a whole lot more in the Python class, by the way, so you guys will get repeat on Thursday, those of you in that class. Another thing that happens in programming is we create these things called variables. And I like to think of variables as, my analogy has always been a box for a variable. And really what a variable is a spot in memory that you're reserving to store something. Variables in Java require designation and identification as a certain type. So what I mean by that is when I have a box, I can put stuff in it. Okay, that's kind of the function of a box. But in Java, that box might only be set up to hold numbers or only be set up to hold words, for example. And so the type of data that we put in the box is relevant. And then that object is named, and then we can refer to it by name. So that's basically the concept of a variable. Often when we're building code, we also start to think about series of steps as what we call procedures. And we can organize those procedures into blocks, name them, and then call those procedures back. So like once you create a sequence of steps that solves a problem, like baking a chocolate chip cookie, I don't have to reinvent those steps in the future. I just say, make chocolate chip cookies, and there's all the steps already pre-built. So that's the concept of calling a procedure. Now, this kind of then leads us to what makes Java also unique from a lot of languages, because it is what we call an object-oriented programming language. And this is, somewhat deep concept that we get to pretty quickly in this course. So in the Python course, this is like the last few weeks of class. In Java, this is like week 3 and 4, so just so you guys are aware. But object-oriented programming basically operates like this. The thought is, once you create code that functionally works and performs a task, there's no reason to recreate that code. You have it created. So if I come up, let's say, with a routine in a program that prints something to the screen or the printer, well, I've created that already. Now the next time I want to do that in another program, well, I can just call that in as an object, which can come in and do that function for me. It's pre-built. It carries its own capabilities. It is its own unique entity at the same time, and then also carries with it a bunch of properties and special features often. And what this functionally does for us is it allows us to rapidly accelerate our program development so that we can use things that are pre-built, which we'll start with. So in other words, the Java language itself has a bunch of objects and classes built into it that we can just call by name and utilize. Wonderful, right? But also in the process of us building programs, we will build programs that will have their own unique capabilities that we can pull into any other program we want. This is really kind of cool because it leads to reusability, rapid development, and some really advanced concepts. And when you start to understand how these concepts work, you can really ratchet it up to even higher level when you see kind of like the beauty of the music of it, because there is kind of a beauty to it. All right. Now these kind of lead to, what I would call some kind of like abstract thinking capabilities here. So this kind of really is a little bit cerebral from the standpoint of understanding it in a figurative way. And what I'm going to use here is this this concept, and they have a little graphic here of the dogs, and I think this is actually a pretty nice little example. The point is that dogs as kind of a combined species all share certain traits, right? So I can say that all dogs on the planet are a member of the class dog. And so this is kind of to explain the objects and classes thing. And the class really is what we call kind of like the archetype of the dog, or if you will, the blueprint to create the dog, or maybe you could even think of it as like the DNA that describes how that dog will be built. But one thing that we can agree on is all dogs have certain common features, right? Dogs typically have 4 legs, they have fur, and see what they do here is like every dog that is created will have a name, an age, a breed, and shot status. In other words, do they have their vaccinations? Right. So this is just a primitive example. Now they create Ginger based upon this blueprint. So she has a name, an age, a breed, and a shot status. But Ginger is a unique entity. She's a certain type of dog with certain colors and markings. And even if I created another dog with the same name and the same breed, it's still a unique dog, if you can see kind of what I'm leading to here. And so this class definition, this archetype or this blueprint, if you will, really kind of becomes kind of like the rubber stamp for all features that are standard to all dogs. So the class is not the dog is the dog, but the dog has the features of the class, and all the dogs do. Now I know this is kind of a deep concept to really wrap your head around this early. Excuse me, but what you'll see is when we get to the later chapters, this has the power that really makes Java kind of special. One of those powers is the fact that those dogs that we create, and once they go from being a class to becoming an object, a thing that is unique, it also carries with it not only these properties, of the name, the age, the breed, and the shot status, but in some cases also carries what we call methods or behaviors with it, which allow you to execute certain actions relative to the animal, and that's what, part of what we call encapsulation. That's what that refers to. And, once again, once you've created that dog, it has all the capabilities of the archetype, and that can translate to all of them. And then it's just a matter of using the right syntax to trigger the behaviors or access the properties. And that's one of the really huge benefits. There's also this thing in Java, because we're using this class and object structure, where we get into this weird terminology where we think of things as superclass and subclass, or parent-child relationship. So like, for example, we have the one dog, and then we can create a subclass of that dog that's maybe a subbreed or has different features, for example. And this concept of inheritance is really important in Java as well, because you can extend the features of one class to another and kind of use them in kind of like this weird sequence to combine many classes together to create like this really cool structure. The other aspect of it is we also have this capability called polymorphism, which allows us to basically, in some cases, throw different data or structures at certain objects and extract other capabilities from them by just doing simple little syntax changes. And we'll see that in action as we move through the concept. Now, I'm going to turn our attention now back to the language itself, as the book does, and talks about Java and how it was developed. So Java was originally developed by a company called Sun Microsystems, a company that now no longer exists. And they originally wrote this language, and one of the main intents of the languages was, and we had this problem with most languages, and including the C-style languages I was talking about. So if I wrote computer code for, let's say, a Windows platform or a Microsoft platform in the old days, and then I wrote it in a certain language, and that language is able to be run on a Macintosh, and I would move my computer code over to the Macintosh and try to run it, it would not run. In many cases, I would have to recode my program to get it to run on that platform because of how that platform worked. Sun Microsystems, identified this is a big barrier to cross-platform development. So this is silly. So we hire a guy to code this out. He gets it to work in Windows. We move over to the Mac and it doesn't work at all. Then we throw it up on the server and it doesn't work there either. And we got to recode it for each platform. So what they decided is, why not containerize the way Java operates, and we will write a language that you only have to, and this is their kind of their catchphrase, you write it once and run it anywhere. So if I write my code on a Windows PC with Java, I can move it over to a Macintosh or a Linux machine or a smartphone or my car's built-in computer or anything that runs Java, and it will run on that platform without changing the code. And that was huge at the time. It was revolutionary, so that's what made Java very prevalent from there on in. So there's that cross-platform capability. Now, Sun Microsystems was bought out by Oracle Corporation. Does anybody know what Oracle Corporation does as their main line of work? Anybody know that one? Well, here's the answer. They do databases. So Oracle is a big database company, in fact, one of the biggest. And they had enough, money in their coffers apparently to buy out Sun Microsystems, and therefore kind of swallowed up the whole Java ecosystem. They are also responsible for overseeing not only their major Oracle database system and the Java programming languages and all the tools that go with it, but also they do MySQL databases, which is really huge on the web, by the way, and a bunch of other big software packages you probably didn't know about. Now, the way that Java programs do operate on a computer is based upon what is a pretty common scheme these days for computer code. In other words, when your computer is operating, your operating system is at the lowest level. So that makes the whole machine go, runs all the key software components that allow the hardware to talk to the software and to the memory registers and all the little peripherals you have attached. The Java programs will ultimately operate inside the Java virtual machine, which is a program that you install, which we did last week. That's the runtime environment, the JRE, that allows Java programs to run. So if you're going to run a Java program on any computer or device, you have to install the Java JVM, some people call it, or the JRE, either one, they're synonymous. And that basically gives us a container, because really what a virtual machine is an isolated container that's protected from the operating system. So meaning if your program crashes and crashes hard, it doesn't bring down your whole operating system, right? It just crashes the program or maybe the container at worst, So that component is required. So before you run any Java program on any computer, you have to install the JVM, AKA JRE. Now, when we write code, we're going to write it at this level. So we're going to write it in the text editor or an IDE. Then we'll hit the debug button and it will show us our syntax errors. We fix all those. And once all of those are gone, we can compile the code into an executable file, which then runs inside the virtual machine. So it's kind of this process. And so this is kind of the anatomy of how most programming languages work these days. With Python, if you guys are taking that class, that goes direct to an interpreter, so it never compiles, which we talked about. But even Windows-based languages these days are often containerized like this. So whenever you code like Visual Studio and you want to run it on Windows, Windows has an equivalent component, which is the common language runtime that it uses for all of the languages that compile through Visual Studio. So if you guys want to, if you know that product and you're trying to make a thing, here's that little acronym, write once, run anywhere. That was a really big selling point at the time, convincing coders back in the 80s and 90s to switch to this language. Yeah, so it does say here, Java is modeled after C++. That is kind of its parent language, and C++ is modeled on C. And like I said, all major operating systems are developed with C languages. But Because it is so close to the syntax of C, if you know any of those styles of languages, you will pick this up very quickly. Now, as we start to write code, we are going to learn that basically there's two different types of software output you can create with Java. The first is what we call console applications, and that's where this course focuses. So we will create code that basically looks like these green screens. You know, this is what it's going to look like. It's not going to be very fancy, right? And it's really not so much about what we're creating visually as the logic that sits underneath. As you get more advanced, you can start to write applications that run within the operating system. So in other words, a window comes up and there's a little, buttons in the corner, and you can make it bigger and smaller, and it looks like a regular program. That's stuff that we do in Java programming too. So after you finish this course and take Java programming too, that's the focus in that class, is GUI, web, and database. Here we will just do a tad little bit of GUI stuff, and we even do it right in the first chapter. So you learn how to create like a little pop-up box, pretty simple thing to do. But those are the two general categories. Most of this class happens in the console, which is typical for first level programming. And the console is inside of your IDE, inside of Eclipse. So it's built right into the product. So it saves us some of the steps that the book shows us. I am going to be taking a break here in just a moment, folks. But before we go into the break, I want to talk really quickly about what we're seeing on the screen here. We'll do a 5-minute break, and then we'll come back and we'll start getting into some of the meat of the sandwich here, as we say. So what they're doing here is they're giving you an example of a Java program. And this is a really simple fundamental program, and you might look at this and go, oh my God, I'll never learn this stuff. But I assure you, you will. It'll become commonplace. But let's take a look at the basic structure here. So we start out with these declarations, and I want you to notice that Java programs, as we build them, they're all called class files, whether it's an executable program or a blueprint for an object. And so you'll always see this class identifier. You often will also see this additional word in front of it, which is an indicator as to what other code or software can access this code from the outside. When there's a public statement, that means any outside program can access this code and run it, which can be useful, or it might totally not be what you want. It just kind of depends. But putting the public declaration is pretty normal, especially if you want to run your program. And then you'll notice that we have a name attached to the class. The convention, and this is not a rule in Java, but it is a convention, is that the first letter of the name of your program should be a capital letter. Now, the reason we do this and we say convention is it's just a practice that most Java programmers follow. So don't think of it as a rule, like you have to have it named with the capital letter first, but it's a convention for a reason. We do this because it then makes it easier to identify what is a class file when you write out code and what is not. If it's all lowercase, it might be a variable. If it's uppercase, that's probably a class. And that's kind of the rationale behind it. You'll notice that after we make that declaration, we then have a set of what we call curly braces, right? And these are, the opening curly brace and the closing curly brace. And some people will call these brackets, braces. Sometimes I just call them curlies, so take it to heart. When I just say curly, I mean curly braces or curly brackets. But you'll notice that there's an opening one. In other words, the concave part of it points to the right, and then there's a closing one here at the end. So our class statement basically starts here with the first curly brace and then closes here at the bottom. Now, sandwiched in between those curly braces is this thing that we call the main method. We're going to get our hands on this real soon. And the main method is the part of every Java program that executes the code. So if it's inside the main method brackets, this code will execute on the system. All right. So kind of reading through this, there's a kind of a lot in here, but basically this means any part of the program can access it. Static means that it's not returning a value. or not changing, excuse me. Void means it's not returning a value. We'll get to all of that later on, trust me. The name of the method, this is a reserve method name, which is the main method. So that's the executing method. And then we have basically a string array of arguments that are allowed to be passed in to make the program run. Now this cryptic looking statement, I assure you, after a couple of weeks of writing Java code, you're going to be public static void main string args. You're going to be like repeating it in your sleep, you know, and you can count on the fact that it will be on your tests, you know, so you'll probably see a question on the midterm. This is how you do a main method, and what's the correct syntax, right? And all of this has to be put in there exactly that way. So the capital letters have to be capitalized. The square brackets have to be there. That's got to be all lowercase. It's got to be just that way for it to work, right? And that's required by Java programs. Now, once we get inside the curly brackets of the main method, now we see actual program instructions. So here we see what we call Java dot notation to create a statement that puts text on the screen. And so here we call the system library, the output library from the system library, and then we call a method called print line. That's how you say that. So print ln, it's not the number one, that's the letter L, and then a set of parentheses with double quotes inside with some words in between. At the very end of the line, and that might be a little hard to see, is a semicolon, which is required as a terminating character for every Java statement, right? So this line, if I execute this program, what will happen is the program will run and it'll put the words in between the quotes on the screen on one line. And that's kind of the first thing we're going to do. And once we get that to run, it's kind of an empowering feeling because then it's okay, what's next? You know, that's kind of how you should feel. Right now we are at 8:57. So folks, I'm going to call a 5-minute break. So I'm going to pause the recording. I'd like you guys to like step up, you know, step out, stretch, go to the bathroom, get a beverage, whatever you need to do. Let's see, it's 8:57 p.m. Let's call it 8:58. So we'll come back at 9:03 p.m. Okay, 5-minute break. I'll see you guys in 5 minutes. My camera and mic will be off. All right, folks, so now the recording is back on. And as I was just explaining, we're looking here at this section where we're kind of breaking down the anatomy of this first type of statement we're going to learn, which is the system out print line statement, and how we identify, first of all, that system is a class structure, that out is a method within that class structure, as is the print line method. And then we have, you know, what we call an argument or a parameter for a method, which is usually within parentheses, by the way. And in this case, we're putting in there what we call a string literal, a literal string of characters that we're going to put on screen. And this is a really fundamental command, but a very useful one that you're going to use many, many times over as you write Java programs. Now, whenever we put something inside of parentheses in a Java program, we call that typically an argument or a parameter relative to where it's coming from and going to. Generally, we call it an argument, meaning that it's something that's added to a statement to increase its functionality or perform a certain function. In this case, to put these words on the screen. So these are the arguments for the print line method. All right, so I'm moving on. So the first thing that we're going to do is understand that as we kind of create our first program here in just a moment, that when we create a class file, that we are going to be using keywords in the language. And Java has a bunch of reserved keywords. Now, I will tell you that these are not all of them that you see on the screen right now, but this is a good number of them that we'll probably use pretty often. Some of these we might not use at all, some we will use all the time. But this is just an example. So if I wanted to name my own objects in Java, I can't use any of these words. I have to come up with a different word to name an object, since these are reserved by the language for specific functionality. Now, one thing that you'll notice is we'll begin building our program, and they do recommend that you follow the valid class name approach. So the first letter should be capital for your class. You can also do what we call kind of camel casing, or basically first letter is capital and then every logical word starts with a capital letter. It's kind of a way that you can identify and read the word a little bit more easily. You'll notice that there's no spaces in the class name. So that's pretty critical. So I can't name a class name and put a space in it, because then it kind of disassociates the words. So you cannot use spaces. You can use numbers in a class name, but you can not start with a number. It has to be somewhere within the string of characters. Here they go into this thing where they say legal but unconventional names, so in other words, here we have names that have underscores in it. That's not usually encouraged, but I do it often myself. Here's one that's all caps, also not encouraged. And here's one that doesn't start with a capital letter but has numbers in it, also not encouraged. Here are some that are downright illegal, that would not work in a program. So first you have inventory item with a space in it. You can't name your program that. It's not allowed, no spaces. Class, I can't use class because class is a reserve word, so that's off the table. So I can't call my class class. Can't start with a number, so I can't start with any numeric characters to name a class file. That's just not allowed. And then I also cannot use special characters like the pound sign or the hash mark, if you want to call it that. So that's something to keep in mind as you're naming things. And so we're going to get into this now, and they kind of give you a little anatomy here. I'm going to kind of do this as I'm coding, by the way. Brock, you got a question?
I do. So the unconventional, the question I had was, what is the reason exactly of why it's unconventional? Is it just because it's not what it's commonly used like, or?
Well, this is kind of weird, and remember, convention doesn't mean rule, right? It's kind of like, the convention is you look both ways before you cross the street. You don't have to, but you might get hit by a car, right? And so the thinking is that we do things certain ways because we as programmers establish patterns that we normally follow. And if we follow those patterns, then other things that we do become easier because we're following a certain set of rules. It's kind of like
it's not going to have any issues in the program running itself.
Exactly. But It might confuse another programmer as to what your intent was.
Okay.
Like, okay, I see the class name is all lowercase. Why did they do that?
So it's like keeping everyone on the same page to understand versus like creating your own thing, but it still works, but the other programmer is looking at it like, I don't know what this is.
Yeah, that's really a good way to put it,
Gotcha.
And thank you for asking the question. All right, so we're gonna go through the anatomy of doing this, but I think what's kind of interesting here is I'm gonna kind of fast forward, and then I'm going to talk about these topics as we fast forward. So here is, I'm not sure exact page numbers here, folks. Looks like we're on page 21. This is the first You Do It application that you'll see marked like this. And what's going to happen here is they're going to coach you to do it a certain way. And some of you maybe will follow this exactly, and others of you will not. And I'm going to be doing this work in Eclipse. So whatever tool you're using to write this code, follow along. So I know some of you might not have a working environment yet, but we'll get to that issue. My main point is to kind of build the program. The first thing that we're actually going to start with, and I know that they tell you to go ahead, open a text editor, create a new document, and then kind of go from there. I always kind of stop dead in my tracks when I get to this point, because I always start with something a little bit more low level that I consider actually more important, which is file and folder structure within your storage space on your personal machine. So most of us are working on Windows machines. And when we do that, we tend to store our stuff in our file manager. So for example, I'm going to bring my file explorer over to my main screen here, and you can see that I have kind of a lot of stuff on my machine, right? Now, many of you will usually choose to take your personal files and store them in your documents folder on a Windows machine. That's pretty normal, and probably a recommended location for your personal machine. And so what you might want to choose to do is in your documents folder is maybe create another folder called Gateway to store your schoolwork. and then create folders for your individual classes. That's really a wise approach. And then what you'll see is you also create folders for your individual homework projects as well inside those folders. Now, I think this is a recommended approach. So you can manage your files any way you want. You know, you want to store your homework in the downloads folder, hey, go for it, as long as you know where it is. I'm trying to give you a methodology for storing stuff in a logical location so that you know where to find it later, you know, because that becomes a number one problem for people. So create a folder, maybe called Gateway or something similar, create folders for each one of your classes, and create a logical structure where you can find it quickly. So I always recommend that first. What I do for my personal file storage, by the way, is I run Google File services. In other words, Google File Stream, which is a variant of Google Drive. This is now available for consumers, by the way, as well, where you can install Google Drive File Stream, they call it, which creates a drive letter on your machine and basically brings your Google Drive to your local machine. However, none of the stuff that you see here, even though it looks like it's on my computer, is actually on my computer. It's all in Google Drive. So it doesn't reside physically on my machine. And that it can be a little bit uncomfortable for people. Another option is if you don't want to put it on your Google Drive, most of us Windows users usually have OneDrive automatically connected to our computers. And if you're running a modern and updated version of Windows 10 or Windows 11, OneDrive, since I think that maybe the 2020 November update that they did, automatically puts your desktop, documents, and a couple of other things into OneDrive automatically, and you don't even know it, by the way. So that might be a good location. So the advantage of that, of course, is, you know, if somebody steals your laptop or you drop it and break it or it falls into a lake, right? All your files are out in the cloud. That's the advantage to working with either OneDrive or Google Drive, by the way. If you choose to manage your files otherwise, that's really up to you. You put them wherever you can find them, but just always make sure that you have backups as well. The one thing I strongly recommend is that you do not use a flash drive or, you know, a USB drive to store your files as permanent storage. Never, ever, 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 ever do that, right? Brock?
Yes, I wanted to point something out about OneDrive for those that don't know. So OneDrive is cloud-based, yes, but to start off, it doesn't give you that much space, and it can get really full really fast. So a lot of these new like Windows 10 updated and stuff that you were saying, when everything you download automatically goes there, it will fill up quick, and it'll want you to pay money to expand that storage. Kind of like how, if for the Apple users out there, kind of like how the cloud works for like iCloud, is that what it's called?
Mm-hmm.
So it's similar in the same fashion as that. So kind of be mindful about, you know, what there's a way to get programs downloaded not on OneDrive, but just keep that in mind that it can fill up pretty quick, and you will have to pay to expand it.
The one advantage to using the Google Drive, at least with school, is I don't know what the cap is for you guys, but I think it's about 30 gig or 50 gig. It's pretty huge. It's a pretty big free repository. You can always use your own local hard drive, but I do really strongly advise never use a flash drive as primary storage, especially if you come to the classroom environment, because I can't tell you how many times people like leave stuff on a flash drive, leave the room, forget their flash drive in the computer, come back days later, it's gone. Or the one horror I saw when I was teaching at the Art Institute in Milwaukee, where I had a student that had their entire academic portfolio, like 4 years of their bachelor's degree, on an external hard drive, got up to go to the bathroom, left the hard drive attached to a machine, came back 2 minutes later and it was gone, and all of her work for 4 years is gone. Right. So that's not a smart strategy. So I want you to keep that in mind. All right. So let's get past all of these mechanics now in file management. And you'll hear this in Python class too, folks. And let's launch Eclipse. So if you've downloaded Eclipse and installed it and it's working, you may have even gone to the trouble of putting it on your taskbar, which I have. So I'm going to start the program and get it up to the first screen here. For those of you that are not able to run Eclipse at this point in time, what I strongly recommend is that you bring up a basic text editor. So depending on your platform. In Windows, you can bring up Notepad or Notepad++, or you could use a tool like Visual Studio Code as a basic text editor. On the Macintosh, you can use TextEdit, Text Wrangler, or any other coding tool. All right. So folks, when you launch Eclipse and you get it up and running, the first screen that you're going to get met with is this workspace screen. And I do want you to notice that you can check the little box and never have to be asked again. Not a big deal, by the way. If you check that accidentally, you can always change the workspace from within Eclipse after it's running. Now, really, all a workspace is a folder where all your stuff is going to be stored. So if you follow the paradigm that I just gave you, you could go through your file system, and in my case, I would go to Documents, Gateway, and I would make a Java folder here and click on it and say OK. Now, because I organize my files a little bit differently, I'm going to find it on my Google Drive, because that's just where I prefer to work. I'm going to find my Java Programming 1 folder, which is already pre-created. And then I have a folder created here called 2022 Spring. Okay, so that's what I would like you guys to do, is create a spot in your folders where you're going to put all the homework for this class. Find that spot inside this navigation screen, and once you have that spot located, click OK. And so this is an example of what I'm doing. This is on my Google Drive, so it's several folders deep. For you, it just might say, C, users, John, documents, gateway, Java 1. Might be something like that. But wherever it is you choose to put it, I'll just say this again, somewhere you know how to find it. All right. Once you have that selection made, go ahead and click the OK button, and then click OK once again, and then Eclipse will finish launching. If you mistakenly choose the wrong spot, we can change it if need be.
As long as you didn't click that one toggle box, it should just bring that back up when you restart anyway. So.
Correct. It should go back to the last one. Now, when I'm teaching multiple Java classes, Anthony, like I am this semester, so I'm teaching Java 1 and Java 2 at the same time, I'm switching folders each time. So like, Tuesdays I'm in this class, Thursdays I'm in the other class.
Yeah, I just meant for if someone did choose the wrong folder, it should just come back up with the option to change it. So
correct. Now, if you guys launched into the program, some of you may have gotten a start screen, like a welcome screen. If you have that screen, you can go ahead and close the little X on the tab for it, and then you'll go into the default setup of the workspace. And now, I know we did this really quickly at the end of last session, but Eclipse and most IDEs have similar layouts. Some of them put certain things in certain spots, others put them in other spots, but there is a commonality. So the first and most notable part of the window is this window in the center, basically, that we do our coding in. For most of you, this is going to be blank right now, unless you've already typed up some code. Then on the left-hand area here, this column is what we call our package explorer. And I want to be really careful to explain, and I think I started doing this last week, that as I kind of hit these little expander arrows here and find my code, that you understand that this is not file and folder navigation. This is project structure and assets. That, yeah, okay, at times they're folders with files inside of them, but there's this other thing here that's a package. That's not a file or a folder, right? And then you have things like the Java system libraries that are all accessible here as well, because they're bundled into the project. And so that's what we call the package explorer. This is where we can see the assets that we have for a project. You can do some rudimentary file management here, but it's not really file management per se. If you're ever really doing file management, you really should be doing it outside of the product, generally speaking. Once we have a program running, like the one that I have here, we'll write our code. check it for errors. Once it's okay, we'll come up to this toolbar here and we'll hit this run button. And that run button will run the compiler to check for syntax errors. If we have no errors, the program will execute and it will open up a console window or a command prompt, which is the bottom part of the screen here. And so the code will run down here for a console program. So for example, I do already have code built here. And I'm trying to get my code zoomed in here. So if you guys can bear with me here a second, I'm going to do just a little bit of adjustment. And basically what I'm doing is I'm just bumping up my font size so you guys can actually read it. There we go. That should be a little bit better for you guys. Everybody okay with the size of the code on my screen? Okay, good. All right, so we're going to go through this process, and I'm actually going to close this file, but we're in essence going to build what you see there. We are going to follow these instructions. And so we're going to start our editor, and we kind of already did that, but we don't have a code window. So how do we create a code window in Eclipse? So that's really our first step. So in Eclipse, what we do is we can either do it on what we call the project node, which is the top folder, or we can expand and go to the source folder, which is really where our file is going to end up. So SRC stands for source. And we're going to give that a right click. And as you right click right on top of that folder, you're going to get this option right at the top that says new. And then we're going to come over to the sidebar here and choose class. So we're creating a new Java class. Now you can also do this from the file menu, by the way. I prefer to do it with a right click. I think it's a bit more efficient. Once you have triggered the new class file creation, now we have the dialog that we use that we're going to get very familiar with. The first thing I'm going to tell you is that one thing that often confuses people in Eclipse is this thing called the package declaration. And I want you to notice how I've left mine blank for now intentionally. Now, really what this does is it containerizes all the code. So if I write multiple programs, I can name them all in one fell swoop. And if not, if I leave it blank, it just stays with the default name, which is fine too. E, I see that you have a question.
Yeah. What if, well, I see that you have this like the package explorer, and then you have the trial run. Are we supposed to open a new one that says trial run, or because, well, I don't have like a source folder. So like, how do I get a source folder?
Oh, I see. Well, see, when we set up our workspace, you know, this actually looks like it's going to dump it into a folder that I had pre-created, you know, because I had done this work last time. I had created, you know, actually, E, you're right. You're totally right about this. Thank you. So what E caught me in is I did a little flub here because I didn't create the project first. What I'm going to do here is I'm going to close my project, and in all fairness, I should probably even remove it altogether. So let's start with a clean slate. All right. So, and I apologize. And thank you, E, for saying that, because really what I did is I neglected the fact that we have to create a project first. So, folks, we are backtracking about a minute here. So if I post this on YouTube, I'll try to edit this part out and jump right to the good stuff. All right. So in the Package Explorer, let's start by creating a new Java project. And the way that we do that is we can hit this first toolbar item, hit the drop down, and create Java project. All right. When we create the Java project, we are in essence creating a folder in our other folder with this name. And so since we're working on chapter 1, and we're going to be basically doing what we call the you do it exercises, I'm going to call it that. I'm going to say chapter 1, you do it. That's what I'm going to call mine. You want to call it something else? You are free to call it whatever you'd like. This will be your folder name. Now, with the project names, you can have spaces and special characters and stuff in it. So if you want to put spaces in, I kind of have this tendency where I don't do that. There's no other selections that we need to make at this point. We just have to click the finish button. And then what that does is it builds what we call the project node inside of the Package Explorer. So this is the root of the project. Notice the little expander arrow next to it, and then you'll see your new source folder. Now I'm going to do the same step I just did just a short while ago, which is I'm going to right click on that source folder, and then I'm going to create a new class file. And then now notice how this is named according to the folder. So by creating the project, it created the folder for me, and that's where it's going to. All right. I'm leaving the package declaration blank on purpose. The question you might have is, when do you actually put a name in there? Well, usually you name your packages when you have multiple programs that will operate in tandem. So in other words, sometimes a piece of software is really more than one program working together. And when those programs are working together, it's helpful to have them in the same container or package. Right now, it's not really important, so we're leaving it blank. Next, we're going down to the name field, and we're going to name the program. Now, this is not a step that you see in the book, because here he's working with a basic text editor. And so the first thing that we're going to do is we're going to look at the name of the class, which is hello with a capital H, and that's what we're going to name ours. So it's going to be hello with a capital H. All right. The other thing that we're going to do here, and there are some shortcut buttons here that we're not going to use right now. We're going to use them in the future. And we're just going to click finish at this point without making any other selections.
Okay, I was gonna say don't forget to click it, but you're gonna go through it. So
yeah, I'm going to come back to that magic button because I do want us to type it out by hand the first time. Okay, so you notice that as it created it, it just basically created the initial part of the program, the same thing that we see in the book. It created public class hello, has an opening curly bracket and a closing curly bracket. All the other code that I write for this program is going to go in between those curly brackets, and that would be code that I expect to execute or operate in any form or fashion. I'm going to begin by creating a little space inside of here. So I just put my cursor in there and hit enter a couple of times. And then notice how it also indented one level. And Eclipse does this automatically. If you're using a straight text editor, or you're using like JGrass, for example, if you've opted that route, that won't happen automatically. You got to manually put in that indent. Eclipse does a lot of this automatically. One of the reasons why we choose the tool. The next thing that we're going to type here is what we call the main method, and that comes with this like whole string of things. So the first thing we type is public, all lowercase, then static, all lowercase. Notice how Eclipse is automatically turning these words purple, showing you that these are reserved words that only Java can use. Next word we put in is void, and then we put in the word main, all lowercase, and a set of parentheses. Now, I kind of do this habit where when I type in parentheses, I open and close them at the same time. It's kind of a little habit I have. And then I arrow back, and then I start typing inside. Inside those parentheses, we're going to say string that starts with a capital S, a pair of square brackets. Now, on most keyboards, those square brackets are usually right above your enter key. And they're also the not shifted part of your curly bracket key. So it's the curly bracket keys not shifted. And then after those square brackets, I'm going to insert a space and then type in args. And a good way to remember that is like think of a pirate, arg, right? Args. All right. When you've completed that statement exactly like that, I want you to add another set of curly brackets. And I do want you to notice how Eclipse, when you put in curly brackets or it generates them automatically, puts the first one after the statement and then drops one in automatically, right? And so the reason it does that is to make sure that this is closed. And this is kind of neat about Eclipse. As I click on one curly bracket, it highlights, it's really hard to see, but it puts a little box around the other so you know which curly bracket matches the one you're clicked on. And I think that's very helpful, right? Because one thing you can lose track of pretty easily if you don't like open and close them right away is, hey, I created this curly bracket, did I ever close it? You know, and that might be a problem. All right, so now we have that statement. Now we go inside of this new set of curly brackets, and here comes our system out print line. This is another statement you'll get a lot of practice with. So we'll start with the keyword system with a capital S. Then we put in dot out. And I want you to notice what's happening in Eclipse here. You notice what's happening? As I'm starting to type, Eclipse is kind of anticipating what I'm typing based on what I put in. And really, it's not any sort of magic. What it does is it recognizes I'm calling the system library. And then when I hit the dot, it says, well, here's all the options that you can put in. One of them is out. Okay, so we're going to choose out. And I can double click it at that point and then type a dot. And then we're going to do print line. And as I type print line, notice what happens. PRINTL. It starts to narrow down all the options, right? And in many cases, you can use this, what we call IntelliSense, to get about a lot of information about what you're typing in, but also to actually get to the point where you're utilizing it. Now I'm going to type print line, and it really is the first one that I want, so I can just press enter and it locks in. And then I also want you to notice that we put in a semicolon automatically at the end of the statement. Eclipse did it, I didn't do it. But if Eclipse doesn't do it, you have to know to do it. That's the terminating character for our statement. Now inside those parentheses, now we do our double quotes. So we do one, I only typed one, but it gave me two. And you notice I put my cursor right in between. Now I can type my first statement. I don't know what the book wants us to do. I think they just want us to say, hello world, right? So let's do the classic hello world, folks. So here we go. Hello world. You can use whatever punctuation you want, exclamations, but there it is, folks. Now, provided you don't have any red underlines. So for example, I'm going to create one on purpose. I'm going to break the word public. And then I want you to notice what happens to the word public when it's broken. It underlines red, and then it'll give me a message. If I hover over it, it says syntax error token on public expected. So it's telling you what it's expecting. So let's put that in so we can correct it. But anytime that you see any of those red marks, if you have a red underline or an X or a red mark in your margin, you know immediately your program will not run. The compiler will stop it because there's an error. We fix that error, and then it's okay and it will run. But I want to demonstrate broken first. You know, this is kind of the backwards way of teaching programming. Let's see how it doesn't work first, and then we'll try to make it work. So the first thing we do here is I'm going to try to hit this run button, the green play button. And then I want you to keep your eye on the console. The selection cannot be launched. There are no recent oh, okay. All right, that's a whole separate issue. All right. Let me see if I can correct this and then try to run. All right, here we go. All right, so now it's asking me to save. And so that was really the issue. So it wouldn't run it because I hadn't saved it. How do I know it's not saved? Well, here's a nice little tip in Eclipse. If you look at the tab, you'll notice that right at the tip of my pointer here is a little asterisk. That's the indicator it's not saved. I will hit the little save icon, or you can do Control S or File Save. And as I hit that, the thing goes away. Now I will hit the Run button, and it says errors exist in required projects. Proceed with launch. Sure, let's try it. But watch what happens is the debugger kicks in down here and says that there's an error. And it tries to give you an indication as to where that error is happening, right? And you know what? They're kind of cryptic. The messages, are sometimes very cryptic and don't make sense. But there's also times where it tries to be pretty specific and point out where the problem is. And that's one of the things that you learn in chapter 1. So what you do here is let's fix the code because we know what the problem is because we broke it on purpose. We'll save our work, and then we'll hit that Run button. And then you see down here in the console, hello world. right? Very exciting. I know this is very primitive, but if you can get this to work, you're well on your way to creating other Java programs. And it's also proof that your coding environment is working correctly. Now, I'm just going to reiterate, we don't really have a lot of time left, but for those that need help getting the environment to work correctly, email me. We'll set up a one-on-one and we'll make sure that you're working. If you're freaking out because you think, oh, my homework's due, oh my God, et cetera, I will take that into consideration for your work being late. Because if your stuff's not working, well, obviously you can't get the work in, so, but you have to let me know. All right, so folks, that's an example of how to build and run the first program. What I'm going to do next is I'm going to move on to the next example in the chapter. And it looks like we won't get to the exercises this time, but the first thing that they're going to start talking about is the compiling and correcting syntax errors. And we kind of done a little bit of this first. Now, this compiling example that they give is for you doing this from the command line. So it is entirely possible in Java to code things at the command line, to execute and run things at the command line. It is really what I would call a stopgap way to work. And not really what professionals do. Professionals don't sit there and intentionally work from the command line just to kind of put themselves through the rigors of it. In the old days, we used to do it this way because that was the only way we could, right? When I was learning this stuff. These days, we have full-blown IDEs where why on earth would we bother to use this approach? So that's why I skip over this. I think it's kind of a waste of time, but if you wanted to do it, you could. So the first thing that you do is you would trigger the compiler to compile your program, and then after words, you learn how to run the program after you correct syntax errors. So if you had like an error in your application, so for example, in this application, they're missing the semicolon. So as they run the program at the command line, there's a little pointer here that goes Java C first with missing semicolon.java, and it says semicolon expected, and notice it has a little pointer that points right to where it's expected. And what this debugger often does is it kind of points to a spot and says, hey, I'm looking for something here and it's not there. And sometimes it's really clear. This is a pretty clear message of what's missing and where to put it. But sometimes you'll notice that when it gives you the indicator, it's not always in exactly the correct spot. The error might be slightly before or slightly after or nearby somewhere. And it's really kind of a matter of interpreting it. You do get used to the error messages after a while and what they mean. Well, how do you figure out, how to fix something? Well, you break it, And so when you break it a certain way, then you figure it out, you understand what the error message ultimately means. And that's really kind of the main thing here. All right, so they have a process for going through and correcting syntax errors, and this is really kind of a matter of practice, and we will do plenty of that. So I'm kind of glossing over this on purpose right now. When you are actually successfully running a Java program from the command prompt, it would look kind of like this. So if you ran hello world from the command prompt, you'd have, hello world here in ugly text, basically. When you are basically taking something that's already built, so for example, the program that we just ran successfully in Eclipse, if you go to the source folder, and I'm going to do this just as a point of example here. So I'm going to go to 2022 Spring. Here's my chapter 1 You Do It folder. Here's my source folder, and there's my hello Java file. This is my code file. It's just plain text, so I can open it up in any text editor and look at it, not a problem. But when I come up here and I go to the bin folder, which is the binary folder, this is where your compiled files end up. There's a class file. This is a result of the compiling. Now, this is even more interesting. If I right click and try to open this in a text editor, you can look at it. This is what it looks like. This is compiled computer code. So if you take any executable thing that's on your system and open it up in a powerful text editor like Notepad++, I can look at compiled code. Now, granted, I don't know what any of this means. I mean, some of it is in English, right? And some of it I even recognize sort of kind of like my code. Like here's hello world. But all this other stuff is only readable by the machine level of the code. So every time we compile a program and run it, it'll create a class file. And then when we go to run it, it is actually this file that runs. Isn't that interesting? So I could go to a command prompt, find this file location, run that program, and it will say hello world for me. Beautiful. That's wonderful. But what they're trying to indicate in the book right now is that after you've already compiled a program, can you still make changes? Yes. You make your changes. So I could go in here and I could, I could basically type another system out print line. So I could say system.out.println. There's my parentheses and my semicolon, and then I'm going to go back in here and add some text in between. And hello, whatever, I'm just kind of throwing words out there. Now I've added to it, and when I go hit the run button, this is unsaved right now, so keep this in mind. The moment I hit the run button, two things will happen, by the way. It will ask me to save, so I'm going to save it. This is the save dialog. And then it'll run it. Now I've modified the program, and the class file has also been modified. So the executable version of the program is what's running down here. Right. So every time we run the program, it recompiles it, turns it into machine code, and now we have a new executable file we can run. So that's kind of the general anatomy here. As you kind of keep moving through these you do it exercises, and so these you do it's, and I am kind of racing through it on purpose, and we will talk about this thing called comments, and we're going to have to push some of this obviously to next week. So what we're going to do here is I'm going to actually put a little bookmark here. This is where we're going to pick up next week. So we're already looking at a scenario where I'm adjusting due dates, folks, on exercises. So I'm going to be looking at the due dates on the chapter 1 stuff. I think I may have set it up correctly where we still have some time. But what you should be working on right now is making sure your tools are working correctly and getting through all the exercises here that are marked as you do it, following the directions as best you can. The next exercise is one where we are creating comments. Comments are basically non-executing code. So it's really information that you put in your program for the programmers or whoever looks at that. From there, we will do this really quick little GUI output where we create a dialog box that looks like this, and we control what words go inside of it. My personal favorite is click here to reformat your hard drive. Or click here to blow up the planet, something silly like that actually doesn't happen, but you may as well have a little fun with it is the way I kind of look at it. And that, I think there's not too much more in this chapter in terms of you do it's. And then, there's also the little exercise where you explore the Java website, but that's kind of it in a nutshell. So you can basically go through those you do it exercises, copy the code that's given you, get it to run, and then you have to turn it in. So now I'm going to extend class by a couple of minutes so I can demonstrate for you how to correctly turn in this homework when it comes time to doing the homework, because this is pretty important. And please don't worry, I will revisit this next week again, and probably for the next few weeks until you guys get it down. Right. So let's say I'm all done with my work, right? I'm like, you know what? This program's working. This is great. I'm really happy. The first you do it exercise is done. So part of what I will need to do in the process of submitting my homework is first read the instructions in the course shell. So I'm going to go to my Unit 1 folder where this exercise is listed, and this is listed as the Chapter 1 You Do It. And I'm going to read through what it says here. It says, complete all of the You Do It exercises from Chapter 1 of our textbook. We did the first. There's a couple more. As you work, take screenshots of your progress, your successes, and challenges. So if something works, I want to see it. If something didn't work, I'd like to see that too. It's kind of what I'm telling you. The screenshots should include your code and executing program. So I want to see both aspects, and I'll show you how to do that in a second. After you take your screenshots, I'd like you to take those screenshots, put them into a Microsoft Word document, and along with a little bit of description as to what I'm seeing and some labeling. Then you will upload that document to Blackboard, and then you will also take your code files, put them into a zip file, and upload that along with your work. Now, getting this perfect the first couple of times. Don't worry about getting it perfect. If you mess up any aspect of this, I'll give you a couple of pointers and ask you to resubmit. And if I docked you any points, you'll get your points. You know, it's not about getting it right the first time. It's about getting it right eventually, and then keeping on doing it right. You know, that's kind of the paradigm here. So here's a demonstration of that whole process. The first thing I'm going to do is I'm going to open up Microsoft Word. And if you have Word installed on your computer, that is the preferred application. The other option, and I'll do this simultaneously, is you can go to your Gateway email account. So I'm going to create a new tab here. Oops, wrong tab, the wrong link. And then I'm going to go to my Google Docs folder, or excuse me, application, which is accessible from the Google Apps icon within your email. So when you log into your email, you hit what we call the waffle icon. That's what they call it at Google, by the way, because it looks like a waffle, right? Like three rows of three boxes. And click on Google Docs, and that brings up Google's document editor. All right, so I'm going to do this in both products at the same time. In fact, I'll start here in the Google product. And so the first thing I'm going to do is I'm going to type something like chapter 1, you do it, exercises. Maybe you want to put you know, your name here, maybe the date. You know, and that's up to you. And, you know, since those are kind of header items, you might want to make them bold or maybe a little bit bigger. And then I'm going to list here, you do it, exercise 1, if you want to number it. And when we do regular chapter exercises, by the way, those will have, you know, exercise numbers like exercise 1.2 or something like that. And so I asked for a screenshot of the code and a screenshot of the program running. And so here's what you do is you use this tool that you have on your system. I'm trying to get myself back to Eclipse here. Here it is, called the snipping tool. And so I'm going to hit my Windows key on my computer. And of course it's not cooperating. And then I'm going to start typing this word, SNIP, and it brings up the snipping tool. And there are 2 different versions of this tool. So I'm going to try to demonstrate both of them. I'm going to use the old tool, which is the one you see on the screen here first, which works just fine. And this tool comes up on the screen, and then I'm going to choose the new button. And you'll notice my pointer turns into crosshairs. And now what I'm going to do is I'm going to click and drag and highlight all the code. And you notice I'm kind of zooming in on it. I'm getting a real tight grab of it. I'm not grabbing all the white space. I'm not doing a print screen to grab the whole screen. I don't want that. I just want the code that's pertinent. There it is. Then I'm going to hit the copy button on the toolbar. Then I'm going to jump over to, I guess, Google Docs first, because this is where I put it first. And I'm going to paste. I'm going to paste in the image. And you notice how that pasted in, the words are pretty large, they're easy to read. They're maybe even a little larger than the font that I'm using. Fantastic, that's a good thing. And then notice how my cursor is flashing here at the end of the image. It means that at the end of the line, I'm going to press enter to move it down and press enter again to move it down again. And then I'm going to go back to Eclipse, back to the snipping tool. And then once again, I'm going to hit the new button. And then I'm going to come down here and show the program running. And you know what? I probably show a little bit of that. So just maybe that's enough. I have my image captured. You guys are noticing I'm not saving any of these images. It's kind of superfluous because I'm making copies of them and putting them into the Word document, which will have the version included. I know some people will save them all and then put them in Word. That's up to you. For my money, I just copy them. I just think it's a whole lot faster. And then I go back to my document editor, wherever the heck that is. There it is. And I'm going to paste in the next image, right? And then what I ask, if you could, is like, this exercise went great, no problems, or maybe like, help, I can't make it work, or, call for help, or whatever your thing is. And you know what? I want to know. I want to know if it worked, it didn't work, what your experience was, or maybe, hey, I tried it a couple times and it failed horribly. By the third time, I figured out I forgot my semicolon and I fixed it, and now it's okay. That's the kind of stuff I'm looking for. So I don't want you just to give me screenshots. I want you to label stuff, and I want you to tell me what's going on. And my primary grading tool here is looking at these screenshots for most of the class. Now, this is one aspect of the document. So let's say I call this chapter 1, you do it exercises. Perfect. Thank you, Google. Then I'll come up here and I'll choose to download this as a Word document, because one of the requirements is that you submit it as a Word document, even if you use Google, right? So I'm going to save this as that file, and then I will go into the course unit assignment listing, and I will click the title. And the first thing I'm going to do here is, first of all, check the due date. Okay, I'm good. Got till Friday. That's all right. There's 2 points on the table here. Make sure that I did all the stuff it says. Okay, so let's say hypothetically I did that. And then I'm going to add that file. Now, this is kind of interesting. If you can pull your file up in a folder window, all you have to do is drag and drop. And once you get inside those dotted lines, it turns purple. Let go. That file is attached. I think that's the easiest way to do it in my mind. Otherwise, you can go to your local file system and find the file and locate it and attach it that way. Or if you use, Google Drive or OneDrive or whatever, you can log into your service from here. My favorite way is the drag and drop approach or the browse local files. That's my preferred method. You can use any of these tools that you want. I would advise to not use the content collection, because then it stores your files inside of Blackboard. Not particularly handy. The next thing I need to attach that I read in the instructions is a zip of my code. So the first thing I'm going to do is I'm going to make sure that Eclipse is closed and the files are saved. Right, so let's close Eclipse and get it off the screen. And then I'm going to go to the file folder where this stuff is stored, which is, for me, in my Google Drive. And you remember, I have kind of a convoluted place. I put it here, Java 1, and then Spring 2022, and Chapter 1, you do it. That's where all my stuff is. And so I don't want to turn in the whole folder. What I want to do is I want to create a zip of this. So I'm going to right-click the folder and then go to this menu here that says Send To. And then you will notice that one of the options is Compressed Zipped Folder. For those of you working on a Macintosh or a Linux machine, Linux file systems and Macintosh file systems essentially have the same tool off of a context click or a right click, where you can right click a file or a folder and zip it. All you have to do is click this button here. It turns it into a zip file, automatically named it. I'm going to press enter to lock in the name. And now I'm going to take that zip file and also drag and drop it with my submission. So here's kind of the thinking. When I get your homework, I look at your screenshot document, and for simple programs, I can see very quickly if you did it right or wrong. Heck, if you do it wrong and you're using Eclipse, it's underlined in red anyhow, right? So you can't really kind of hide the mistakes. The IDE kind of shows them to you. If I have any questions about whether or not the program is valid, or if it runs, or if you have an issue with it and you need help fixing it, I then go to the zip file, I unzip it, take a look at your code and try to run it myself. And then I, often can find the problem that way. But, the other aspect of this, right? So usually the screenshot documents are the primary grading mechanism. But the secondary advantage of turning in your code in a zip file is now I have a backup in Blackboard. So let's say tornado strikes, takes out your house, blows up your laptop, lightning strikes and, kills Google servers and it's off the Google Drive too, or whatever happens that's bad. Blackboard's got a copy of your code now, And the neat thing is that it'll stay in Blackboard for a couple of years. So if you ever lose your code and you want to bring something back, I can, get it for you basically. And so that's kind of the nice secondary feature. When you're all done, if you want, you can add some comments down here, or you can write me a message up here in the right submission area. You just hit the submit button, and then off it goes to me. Now, I can't turn it in, but on my end, when I receive that, the Word document becomes really important, because the Word document will auto render inside of Blackboard grading environment, and I can grade directly from it. If you mess up any of those steps, don't worry, we will repeat this process a few times so you get used to it. Some of you have already had me for classes and know the procedure, so it's same old for you guys. But for anybody that's new, I'm usually pretty lenient on the front end to help you through the process until you get my procedures down. And once you have those down, you will notice that a lot of our instructors use the same approach, where we have screenshots and then a zipped code often, and it usually takes both of those to verify something is done. Once you have something submitted, I usually take about a week or two to grade it. Typically, on the front end of a course, I usually try to be pretty aggressive at grading so you guys get the procedures down. But like I said, we're going to review all this stuff. And if you have questions on it, we'll probably have to save them mostly for next time. This recording ends here, by the way. So I'm going to terminate the recording.